Okay, so this is the solutions to practice 5A. So practice 5A solutions. Okay, so the first question was simply to evaluate, and they gave you -2 to the 6th. Well, remember what this means, right? This means -2 times -2 times -2, and I need 6 of them. So then, I guess the quick way to do this, right, is think of a negative times negative times negative times negative times negative times negative is a positive, right? If we have an even number of negatives and you multiply them together, you're going to get a positive. If you had an odd number, it would be a negative. In this case, it's 6, so it's even. And then if we just do 2 times 2, so this is positive, it'll be 2 times 2, 6 times. Well, this is 4, right? Then this will be 8, then 16, then 32, and then finally 64. And it'll be a positive 64, again, because I'm multiplying 6 negative numbers together. So positive 64 is the answer, and that is D in this case. So you just have to multiply them out. That's all you have to do. All right, question 2. This is one of our rules, right, for exponents. Remember, if the exponent is a 0, then anything raised to the 0 power, as long as that thing is not 0 itself, anything else raised to the 0 power, by definition, this is equal to 1, right? So this is also going to be D. By the way, what if you did have 0 raised to the 0? Well, this is undefined. So that's why they say the actual number that's being raised cannot be 0, right? Anything else raised to the 0 power is equal to 1. So if you happen to have 0 raised to the 0, that's undefined. And then another rule, so question 3, was what if I take anything, so in this case -3xy, and raise it to the 1 power? Well, that just gives you back the same thing. Right? So this is simply -3xy again. So that's going to be A in this case. Okay, 4. If I have w to the 6th times w to the 3rd times w squared, how do I simplify this? Well, this is the product rule, right? Remember, if you multiply a bunch of powers together and they have the same base, then the product rule says you keep the base and you add the exponents. Well, what's 6 plus 3 plus 2? That's 11, right? So this will be w to the 11th power. So that should be B in this case. Okay, 5. So now we have m to the 8 divided by m to the 6th. And in this case, right, if we're dividing two powers and they have the same base, we use the quotient rule. So remember, the rule here is you keep the base, so keep the m, and you subtract the exponents. So 8 minus 6 is a 2. So the result is just m squared, right? M to the 2nd power. So that's also B. Okay, 6. All right, so in this case, I have S, R to the 5th, T to the 4th, over R squared, T to the 6th. And I want to simplify this, and I want to write it with just all positive exponents. I don't want any negative exponents, okay? So the first rule I'm going to use is the one that I just used in question 5. It's the quotient rule, right? So first of all, S, there's no other S, so I can leave that there. And then r to the fifth over r squared, well, it's the same base, so I keep the base, and then I would subtract the exponent. So 5 minus 2 is 3. And then t to the fourth divided by t to the sixth, same base, so I keep the base t, and I subtract the exponents. What's 4 minus 6? Well, that's the same as 4 plus a negative 6, so that's a negative 2. Okay? But we're not quite done yet, because remember, the answer cannot have any negative exponents. They don't want us to have any negative exponents. So in this case, the s and r cubed are fine. I can leave those in the numerator. And then the t to negative 2, I can bring that down to the denominator. And remember what happens if I move something from numerator to denominator, or vice versa, denominator to numerator, you just change the sign of the exponent. So if I move it down to the denominator, that becomes a positive 2. And that's exactly what we want, right? We want all positive exponents. So in this case, the answer should be B. Okay, number 7. I have a cubed times b to the negative fourth. So we want to rewrite that with only positive exponents. So this is similar to what we just did, right? The a cubed I can keep in the numerator, that's fine. And then the b I'll move down to the denominator, but what is the new exponent now? It's going to be a positive 4. Right, so it's going to be a cubed over positive 4. That is also b. Number 8, I have y to the negative 15 divided by y to the fourth. Again, this is just the quotient rule, right? So I keep the base, and I subtract the exponent. So you have to be a little careful here. This is negative 15 minus 4. Well, what's negative 15 minus 4? That's negative 19. And then if we want to write it so that there's no negative exponents, I would put that y in the denominator, right? But what's in the numerator? Remember, you always have a 1, right? There's always a 1 there, so I can leave the 1 in the numerator, put the y in the denominator, but now instead of negative 19, this becomes positive 19. So that would be the answer, 1 over y to the positive 19. So this is D. Okay, number 9. Let's see. Solve the problem. The cylindrical storage vat in the picture has a base with radius r and a height of r. The volume of the vat is the product of its height and the area of the base. Find the volume of the cylinder. Okay, so they give us a cylinder, right? Let me see if I can draw this out. So something like this. They tell us that the radius is r, right? It's r meters, and the height here is also r, right? These are meters for the measurement, meters. And they want us to find the volume of the cylinder, and they're saying that the volume of a cylinder is the area of the base. So that's the area of either this, the base, or the top. Either the top, they say the base, but it could be either the top or the bottom. So area of the base times the height. But what is the shape of the base? It's a circle, right? And remember, the area of a circle, so in this case I'll call it area of the base, which is a circle. The area of a circle is pi r squared, right? So it's pi r squared. So in this case, the volume is going to be pi r squared, that's the area of the base, and then the height also happens to be r, but now we can combine those together, right? Because what's r squared times r? Remember, that's the product rule. You have to add the exponents. So this will be pi r cubed, right? Because 2 plus 1 is 3. So it's pi r cubed, and then it has units of meters cubed in this case. So the volume is just going to be pi r cubed with units meters cubed. So it looks like it's going to be B. Is the correct answer. Okay, 10. Simplify. So they give us a squared over b cubed, all raised to the third power. Okay, so remember, right, we have that rule that says if I raise a quotient to a power, then the numerator gets raised to that power. So the numerator gets raised to the third power, and the denominator gets raised to the third power. Then I have to use another rule, right? This is the power rule. If I take a power and I raise it to a power, then the rule is you multiply the exponents. So this would be A, and then 2 times 3 is 6, and then B, 3 times 3 is 9. So that would be the correct answer. So it should be A to the 6th over B to the 9th. So it should be A in this case. Okay, 11. So in this case, I have negative 3m over n squared raised to the negative 4. Okay, so this one's going to be a little bit of work, but first thing, remember when I have a quotient raised to a negative exponent? What you can do, the rule is you can flip the quotient inside, so I can flip that fraction inside, and then this becomes a positive 4. So that's the first step, okay? Then now you can think of it as I'm raising a quotient to a power, so that means the numerator gets raised to the 4th power, and the denominator gets raised to the 4th power. Now, in that denominator, so let me write the numerator over again. I have n squared to the 4th. In the denominator, I have a product raised to the 4th power. So that means that each term can be raised to the 4th power. So if I split that up, this is saying negative 3 should be raised to the 4th power, and then m should be raised to the 4th power. Okay, so now let's work this out. Well, I still have one more thing to do. I can use the power rule in the numerator. I have n squared raised to the 4th. So remember the rule is you multiply the exponent. So this would be n to the 8th. Then I have negative 3 to the 4th. I'll do that on the bottom here. Remember what that means. That means negative 3 times negative 3 times negative 3 times negative 3. Well, a negative times negative times negative times negative is a positive, right? Because there's an even number of negatives. And 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So this is going to be a positive 81. And then I still have an m to the 4th. So that would be my answer. It would be n to the 8th divided by 81 m to the 4th. So it looks like it's going to be C. Okay, so we have to do this step by step, just applying our rules for the exponents. All right, so number 12. I have m to the 7th, n to the 6th over m to the 4th, n cubed, all raised to negative 1. So actually, first thing I would do is make that exponent a positive. I have a quotient raised to a negative exponent, right? So flip the quotient inside, flip this fraction. So this is m to the 4th, n cubed, over m to the 7th, n to the 6th. And now this is raised to the positive 1. And of course, anything raised to the positive 1 is just itself. So this is just going to be m to the 4th, n cubed, over m to the 7th, n to the 6th. All right, now we can use the quotient rule, right, for the powers, for the m's and for the n's. So if I have m to the 4th divided by m to the 7th, I keep the base and I subtract the exponents. Well, what's 4 minus 7? That's negative 3, right? So 4 minus 7 is negative 3. And then for the n's, I do the same thing. I have n to the 3rd divided by n to the 6th, so it's n to the 3 minus 6, but 3 minus 6 also happens to be negative 3. And then I want to rewrite this so that there's no negative exponents. So in the numerator, I'm going to leave, remember you always have a 1 there, right? So I'll leave a 1 in my numerator. I'll bring the m down to the denominator, but then what happens to the exponent? It must change to a positive 3. I'll bring the n down, and it also changes to a positive 3. So that's going to be the correct answer. So in this case, it's going to be A. Okay, 13. Write the number without exponents. Okay, so they give us a number in scientific notation. So 7.393 times 10 to the negative 5th. Again, a quick way of thinking about this, 10 to the negative 5th, that means a very small number, right? Because I'm multiplying by 1 over 100,000, basically. So it's a very small number. So to get the number in standard notation, I just move that decimal place. And which way would I move it? Well, since I know it's going to be a small number, I must move it to the left 5 places, right? That depends on the exponent. So 1, 2, 3, 4, 5. So I'm going to put in 4 zeros there. And that's going to be my result. And then you can always put a 0 in front. That doesn't matter in front. So I have 0, 0, 0, 0, 7, 3, 9, 3. That's the same exact number, but now it's in standard notation. So it looks like, let me make sure I have the right number of zeros, 4 zeros. It looks like it's going to be D on our practice sheet. So D, okay. All right, 14 is just going the other way. So now they give us a number written in standard form, and they want us to write it in scientific notation. Okay, so remember, when standard form, right, if it's just an integer like this, the decimal to start with is at the end, right? It's not written there, but it's at the end. So I need to move it, if I want to write this in scientific notation, I need to move it between the two 8s, right? Because I always want a number that's greater than or equal to 1, but less than 10. So it has to have a single digit and then a decimal point. So this will be 8.8 times 10, and then since I moved it 4 places to the left, I have to put a 4 in my exponent, right? So it's as if I'm multiplying by 10,000 in this case. So however many places you move to the left, you add that to the exponent. If you move to the right, then you subtract from the exponent. In this case, we had to add it to the exponent. So this should be 8.8 times 10 to the 4th, which is B. So B would be the correct answer. Okay, 15. I want to multiply these two numbers in scientific notation and then leave the result in scientific notation. So I have 4.8 times 10 to the negative 3, all multiplied by 8.5 times 10 to the 6th. Okay, so remember, to handle this, multiply the numbers first, and then we'll worry about the powers. Really, everything's being multiplied together, so we're just going to rearrange terms. We're going to multiply the numbers first. So if I do that, let's do this in the calculator. I'm going to get 4.8 times 8.5. That's 40.8. This is 40.8. And now I'll handle the powers. Well, 10 to the negative 3 times 10 to the 6. I'll do that over here. 10 to the negative 3 times 10 to the 6. Remember, you keep the base and you add the exponents. Well, negative 3 plus 6 is a positive 3. So this is times 10 to the 3rd. But I'm not quite done, right? Because I don't have it quite written in scientific notation. I need to move that decimal So it's between the 4 and the 0 to make sure that this is in scientific notation. So to correct this, right, I need to move this one place to the left. So what do I do with the exponent? Well, if I move to the left, I add 1 to the exponent, right? If I move one place to the left, I need to add 1 to the exponent. So this would be 4.08 times 10 to the 4th. Think of it this way, right? If I move one place to the left, I've sort of like divided by 10, so I need to multiply by 10 to correct it, right? So effectively, I've done nothing at the end. So since I move 1 to the left, I correct the exponent by adding 1. So the answer should be 4.08 times 10 to the 4th, which is C in this case. Okay, 16. Oh, now we're dividing numbers in scientific notation. So I have 25 times 10 to the 6th divided by, I'll write it this way, 5 times 10 squared. So I divide the numbers first. So 25 divided by 5 is just 5. And then 10 to the 6th divided by 10 squared, use the quotient rule. So I keep the base 10, and then I would subtract the exponent. So 6 minus 2 is 4. And this is already in scientific notation, right? You can think of the decimal is right there. So that's fine. So that should be the answer. So 5 times 10 to the 4th, it should be C. Okay, 17. So you're given this polynomial, right, in one variable, just in terms of x. And we're asked to write it in descending order. So remember, descending order means start with the term of highest degree. So the term with the highest exponent, so that's 6x squared. And then decrease from there. So then minus ax. And then the last thing, if there is one, should be the constant. So that's it in descending order. And then what's the degree of the polynomial? Well, the degree only depends on the leading term, right? The degree of the polynomial is the degree of the leading term. So in this case, the degree is 2, right? It's second degree polynomial. So the correct answer should be A. Identify the constant term, the leading term, and leading coefficient. Okay, so I have 5x to the 6th minus 9x to the 7th plus 10x squared minus 8. So first of all, let me write this in descending order. So the highest term, right, is a negative 9x to the 7th. That's our leading term. Then we have plus 5x to the 6th plus 10x squared minus 8. So the leading term is, actually they want the constant term first. Let's do this in the correct order. Constant term, so that's just a negative 8, right? That's the constant term. Then they want the leading term, that's negative 9x to the 7th. And then they want the leading coefficient, which is the coefficient of the leading term. So that's just negative 9, right? If this is the leading term, then the coefficient of that term is negative 9. So it looks like in this case, for 18, it's going to be, looks like A again, right? So negative 8, negative 9, x to the 7th, and negative 9. Yeah, so it's going to be A. Okay, 19. Combine like terms and write the resulting polynomial in descending order of powers. Okay, so they give us the polynomial 8x to the 8th minus 7x to the 7th minus 5x to the 6th minus 2 plus 3x to the 8th minus 5x to the 7th minus 5x to the 6th plus 8. Okay, so all we're doing is combining like terms here, right? So I have an 8x to the 8th and a 3x to the 8th. So what's 8 plus 3? That's 11, right? So 11x to the 8th. Then do I have, let's see, x to the 7th terms? Yeah, I have a negative 7x to the 7th and another negative 5x to the 7th. So that's negative, what, 12x to the 7th. Then x to the 6th terms, I have negative 5x to the 6th, another negative 5x to the 6th. So minus 5, or negative 5 minus 5 is negative 10x to the 6th. And then for the constants, I have a negative 2 plus 8. That's going to be plus 6. Okay, so that should be it. So let's see, 11 x to the 8th minus 12 x to the 7th minus 6 x to the 6th plus 6. It looks like it is again A. Okay, 20. We're given a polynomial, 7x squared plus 3x minus 5. And we want to evaluate it for a particular value of x. In this case, x equals negative 2. So how do I do this? Just plug it in, right? Just plug it in, but be careful when you evaluate it because it's negative. So it's negative 2, the whole thing is being squared, plus 3 times negative 2 minus 5. So order of operations, I need to do the exponents first. Well, what's negative 2 times negative 2? That's a positive 4. Then I can do my multiplications, right, left to right. So 7 times 4 is 28. 3 times negative 2 is a negative 6. And I have a minus 5 here. Then addition and subtraction, do left to right. So 28 plus a negative 6 is a 22. And then 22 minus 5, I guess, is 17. So it looks like 17 is going to be the answer. So that should be C. Okay, a few more. Question 21. We want to add these two polynomials. Okay, so they give us negative 2 minus 4x to the 5th plus 5x to the 7th minus 6x to the 6th. And we want to add that to 4x to the 6th minus 5x to the 5th plus 3 plus 9x to the 7th. Okay, now since I'm not subtracting anything, right? I don't have anything out in front of the parentheses. I can just remove the parentheses. So I'm going to do that. I'll remove these parentheses and write down all these values again. And now to add these, it's a matter of just simplifying by combining like terms. Right, so now I'm just going to combine like terms. And I'll do it in descending order. So I'll look for the highest powers. So I guess x to the 7th is the largest. So I have a 5x to the 7th plus 9x to the 7th. So 5 plus 9 is what? 14. X to the 7th. The next highest is the 6th power, right? So negative 6x to the 6th plus 4x to the 6th. So negative 6 plus 4 is negative 2x to the 6th. Then looks like the 5th power, right? So negative 4x to the 5th minus 5x to the 5th. So negative 4 plus a negative 5 is negative 9x to the 5th. And then finally, the constants. Well, negative 2 plus 3 is just a plus 1. So 21 should be, it looks like B. Yeah, 21 is B. Okay, 22. So I want to subtract these polynomials now. So I have 10n plus 5n to the 6th plus 8n cubed, and I'm going to subtract, and I have minus 13n cubed plus 7n to the 6th minus 5n. Okay, so the first polynomial, right, since there's a 1 out front, I can just remove those parentheses. I'm fine, so I'll just do that. And now, if I'm subtracting the second polynomial, remember you can add the opposite, or the best way to think about it is you really have a negative 1 out front here, so distribute in that negative 1. It's going to change all the signs. So negative 1 times negative 13n cubed becomes positive 13n cubed. Negative 1 times 7n to the 6th becomes negative 7n to the 6th. And negative 1 times negative 5n becomes positive 5n. And now I'm just going to combine like terms. So, and I'll start with my highest powers right at the beginning. So I'll do descending order for my result. So I have 5n to the 6th minus 7n to the 6th. Well, 5 minus 7 is negative 2n to the 6th. Then let's see. It looks like n cubed is the next highest. So 8n cubed plus 13n cubed. Well, 8 plus 13 is what? 21. So I guess this is plus 21n cubed. And then the next highest are just the n's. So I have 10n plus 5n. Well, 10 plus 5 is 15n. So for 22, it looks like it's going to be B again. Yep. So B is the correct answer. Okay, 23. So now we're sort of like adding and subtracting polynomials, right? So I have 3m squared n squared minus 2mn plus 1. Then I'm adding 9mn minus 3, and then I'm subtracting 4m squared n squared minus 30. Okay, so the first polynomial, right? There's no issues with signs, right? So I can remove those parentheses and I keep the same signs. So just write down the terms again. Plus 1. Same thing with the second polynomial, right? So this is just 9mn minus 3. But then the third one, I have to distribute in at negative 1. So it's going to change the sign. So this is going to become negative 4m squared n squared. And then negative 1 times negative 30 is plus 30. Okay, so let me combine like terms. So 3m squared n squared. Do I have any more m squared n squared? Yeah, it looks like I have 3 and then negative 4. So that's going to be minus 1. But you can write minus 1 as just minus m squared n squared. Then I have mn's, right? So I have negative 2 and then plus 9. So negative 2 plus 9 is 7, positive 7 mn. And then finally for the constants, I have plus 1 minus 3, so that's going to be negative 2. And then negative 2 plus 30 is a positive 28. So that should be my my answer when I add and subtract those polynomials together. So it looks like in this case, it's actually going to be A. Okay, and then the final question. It says the number in thousands of male employees working for a certain company can be approximated by negative 0.1x squared plus, so for male employees, number of years, okay, hold on a second. The number of male employees working for a certain company can be approximated by the, okay, so the number of male employees can be approximated by this polynomial. 0.1x squared plus 7.2x plus 6.2, where x represents the number of years since the company first opened. The corresponding polynomial for female employees, so number of female employees, is 3.9x minus 1. And what they want us to find is find the polynomial that represents for a given year how many more male employees than female employees there were. So if I want to know how many more, then I want to find the difference, right? So basically what I want to do is I want to take the number of male employees, which is represented by this polynomial, right? And I want to subtract the number of female employees, which is represented by this polynomial. Okay, so how do we do this? Well, we know how to do this. The first polynomial, I don't have to worry about changing any of the signs, so I'm just going to write this down again. And in the second one, you'd have to distribute in this negative 1, right? So this is going to be negative 3.9x and then plus 1. Right? It changes both of the signs because I'm multiplying both terms by negative 1. Now I'm just going to combine like terms. Well, the only x squared term is the first one, so that just stays 0.1x squared. And then I have 7.2x minus 3.9. Well, what's 7.2 minus 3.9? Well, that's going to be 3.3, right? So this is plus 3.3x. And then 6.2 plus 1 is 7.2. And that's it. That should represent how many more male employees than female employees there were, because I found the difference between those two polynomials. So in this case, it looks like it's going to be A. And this is really 1,000, right? 1,000 employees. So it looks like A is the correct answer. Great. So that's it for the practice on section 5A. And the next thing I'll do is I'll do a video lecture on the 3 sections for 5B.